So we're going to work an example of a Newton's law problem using two masses, a pulley, and a ramp. So in this problem, a 10 kilogram block is attached by a pulley and a string to a 2 kilogram block, sitting on an inclined plane at an angle of 56 degrees. Now a couple key points. The first thing is that we're going to rotate the axis, so this would become our x-axis for block 2, this would be our y-axis for block 2, and this will be our y-axis for block 1. The second key thing to note is that your acceleration in the y direction for block 1 equals your acceleration in the x direction for block 2. And we know this because block 1 is attached by this pulley and string to block 2. So if block 2 goes down the ramp, block 1 goes up. So now let's look at what we do next. So just like any other Newton's law problem, we're going to draw force diagrams. So if I look at block 1, it has the force of gravity, which is m1g, balanced by tension. And then if we look at block 2, again noting that this is the x direction for block 2, this is the y direction for block 2, we know that we have gravity, weight is pulling down, we've got the normal force on block 2, and we have tension right here. Now something to note, this tension is the same as this tension because you can't pull harder on one side of a string than another. So we're going to start by examining block 1, and the first thing we know, start with Newton's second law. Sum of forces in the y direction equals m1a_y1. So this block's going to go up. Now it is accelerating, and again, always work one side to another, so we know m1y_y1, just bringing this side down, equals tension plus, and then pulling down we have minus m1g. So we solve and we get tension equals m1g plus m1a_y1. That's our big result for this side. So now if we look at this block, it's a little bit more complicated because we've got this angle. There's no friction in this problem, so we're going to use the y direction here. It's not going to really matter. All we care about is this x direction. So if we're setting up the x direction, it's accelerating, so we've got m2ax2 over here equals sum of forces, tension pulling in the negative direction, plus m2g, and since it's the component right here, it's the opposite side of this angle, so we use sine. So m2g sine theta. If we solve this around, I'm just going to rearrange it so I can write it a little easier. m2g sine theta minus t equals m2ax2. So now we're at the part where we can plug in t from what we got before. So starting with this equation, we're going to go and expand this t using what we have before. So we have m2g sine theta minus the quantity m1g plus m1a_y1 equals m2ax2. Now we remember, this acceleration is the same as this acceleration. So if they're the same, then we can just write them as the same thing. So let's do that and get all of our a's. So I'm going to take this term, put it over on this side of the equation. So I get m2g sine theta minus m1g equals m1a plus m2a. And what I'm going to do, I'm going to group this m and this m because there's a common a on both sides. And I'll rewrite this as m2g sine theta minus m1g equals m1 plus m2 a. And we're almost done. Okay, so we're almost done. Let's move this over, and we'll get m2g sine theta minus m1g over m1 plus m2 equals a. So let's plug in our masses. We've got 10 kilograms times 9.8 sine 56 degrees minus 2 kilograms times 9.8. This is meters per second squared. This one here also meters per second squared. That was a very bad habit I did. Over 12 kilograms equals your final result of 5.14 meters per second squared. And that is how you work the block on a ramp problem. So if you have any questions, please feel free to email me or stop by my office, and hope this was helpful. Thanks.